when we're developing a wind farm, we're replacing wind turbines, we apply a lot of setbacks. Each project, we start from a blank slate and we start going through each of the setbacks or distances from kind of everything that's in the project area. And as we sort of whittle down the site to where we can really place turbines without being a burden on the neighborhood. Here I have an example site. So this is wind farm in Michigan, a real site. And I've just pulled a subset of the site out, and it's just one township. So it's 36 square miles, one township, and it's about 2/3 of landowners are part of the project, are participants in the project. And what I'm going to walk through is the typical setbacks that we would apply to a project of this type to come from the total site bare earth, no constraints to what we can actually work with to build. We start with a setback on the project boundary of just, this is twice the hub height, but we might reduce that or increase that depending on what's outside the project. But this is just, we want to stay a little bit back from the boundary of the area we're working in as a courtesy to those who are not part of the project. We also consider where there's dense populations or there's municipal areas, so cities, villages, and so on. So in this case, we have a small village in the corner of the project, and we have a 1/4 mile setback from the legal boundary of that village, which is also where almost every resident is right on the main road. So that just keeps us back away from sort of concentrated areas of development. We also have transportation setbacks. In this case, we're using 1.1 times the total turbine height, so the total height plus a little bit of margin, and we apply that to every public road and every other public right-of-way or private right-of-way that is of significance. So we have one railroad in this example, and then roads on almost every single mile. And so we use that total turbine height setback on roads. We also have in this project about 4 roads that are paved in this region that are also very heavy traffic. So we apply an additional margin, about doubling the base setback on those heavy use areas. And that's not a strict requirement, but it increases our safety, it increases our comfort, it makes for a better project. We have an alternative where we can site turbines within about the 550 foot or so that we were using for every other road. But in the winter, if there was ice buildup, we would have to shut those machines down. And we would rather avoid that by staying farther back. And where possible, we'll do that on all roads, but we do consider high use areas versus low use areas. We also have overhead utilities. In this case, this is transmission lines, distribution lines, so home service, telephone lines, and other overhead communications. It's mostly communications. And we have a setback again of the total turbine height plus a little bit of margin for these. And I don't believe there's ever been, that I'm aware of, any incidents with public utilities, but the utilities would like the setback, we would prefer the setback, and it's usually not a large impact. On this area I'm showing as an example, there's really one line that cuts through the site, and it's pretty easy to stay back from it and not have any negative impact. We also have licensed communications. We do consider FM and AM radio, we consider television, we consider cell phones, but most of those have what we call omnidirectional, so the antennas are not line of sight, they're not point to point, they're broadcast. Microwave communication is a very common communication. It's used for internet backhaul, it's used for communications of utilities to their substations. It's used for bringing cell phone traffic from the remote towers back to more central locations. And that is a point-to-point, narrow-band kind of communication. And so we do a study and identify where those licensed paths are from the FCC. And then we have a setback there, so we're not breaking a line of sight with our machines. We also have usually requirements for non-participants, for people who don't want to be part of the project, so we stay back from their land. And our recommended distance is usually, again, kind of that total turbine height. That's a nice, easy thing to use where if it ever did have an issue, it'd be very, very unlikely it would ever affect the neighboring land. The minimum setback we might otherwise use would be just the turbine blade radius, so we were not encroaching And that is usually sufficient, but people prefer a bigger distance. So we usually use a bigger distance. And the last one I'm showing here is I call occupied structures, but it's mostly homes. But we also include churches, we include schools. If we had places of business, offices, we would also include offices. So we include those, and that has a minimum setback usually of about 1,000 feet, just absolute minimum. And then we usually apply closer to a 1/4 mile for most of those buildings as our preferred. And where we can, we go higher. And where it makes sense, we go higher. Because those are our areas of kind of most concern. That's where people live, right? So we want to really take that in consideration. What that leads us to then is we've put a whole bunch of setbacks on here. We might also, on top of what I'm showing in this slide, apply additional environmental, wildlife, wetland setbacks. They're not included in this map. This site has very few of those areas. But that is part of our process as well. And we come to, anywhere from as low as maybe 15% of a total area might be left up to maybe 30-35% from what we started with, depending on just how heavily populated it is and how many constraints and what setbacks we're using.